Most chatbots cannot remember what you said 5 minutes ago. You tell it your dog's name is Baxter, you tell it you are allergic to shellfish, you share your flight details, and 20 turns later, it's forgotten everything. The question isn't whether memory matters, it's which memory architecture actually works. So I built a benchmark to find out. This is the agent memory showdown. For this experiment, I'm using LangChain. LangChain gives several ways to handle conversation memory. Each makes a different trade off between recall, speed, and cost. We will discuss four methods here. Buffer memory, the native approach. Just pass the entire conversation history into the prompt. Works great until your context window explodes and the API bill goes through the roof. Summary memory. An LLM compresses the conversation into a running summary after every turn. Sounds clever, but what happens when the summarizer decides your flight date isn't worth keeping? Vector memory with Qdrant. Embed every message into a vector database. At query time, pull back only the most semantically relevant snippets. Surgical and efficient. Vector memory with pgvector. Same idea, but with PostgreSQL with the pgvector extension instead of a dedicated vector database. One less service to manage. The question, when you push these to 50 turns with 10 planted facts, who survives? Here is how the benchmark works. I spun up a DigitalOcean Droplet, 8 gigs of RAM, 4 vCPUs, Ubuntu 24.04, running in Bangalore. On it, a Qdrant container and a PostgreSQL 16 with the pgvector extension. The LLM is Claude 4.5 Sonnet, accessed through DigitalOcean Serverless Inference API. Embeddings are computed locally using sentence transformers, the AL Mini LM L6 V2 model. The benchmark generates a synthetic 50-turn conversation. It covers travel planning, tech preferences, personal details, work projects, normal chatbot territory. But hidden inside the conversation are 10 specific facts planted at precise turns. At turns 15 and 50, the benchmark pauses and quizzes the AI on every fact it should know. This builds the memory decay curve. How much does each backend forget over time? Each backend runs 5 times for statistical reliability. That's 4 backends into 5 runs into 50 turns. That's equal to 1,000 LLM calls minimum. Let's start with the most important metric. Can it remember? At turn 15, all 4 backends achieve 100% recall. Only 4 facts have been planted. They are recent and the conversation is short. No challenge here. But at turn 50, after 10 facts spread across the full conversation, the story changes dramatically. Buffer is at 90%, nearly perfect. It has the entire conversation in its prompt, so of course it remembers. The only failures are the Wi-Fi password and the bank PIN, and we will come back to this later. Qdrant and pgvector, 82%. Solid performance. The vector search finds the relevant snippets most of the times. And in summary, 42%, less than half. Let's look at this breakdown. Summary remembers facts from turns 1 through 12 perfectly, but everything after turn 18, almost zero. The summarizer compressed away sister's wedding location, the book you're reading, the supplement dosage, all gone. The summary backend doesn't just forget old things, it actively destroys new information as it compresses. Now let's talk about speed. This chart shows latency per turn across the full conversation. Qdrant and pgvector stay flat around 7 seconds per turn regardless of conversation length. They only retrieve the top k relevant snippets, so prompt size stays constant. Buffer starts at 3 seconds but climbs to 12 plus seconds by turn 30 as the entire conversation history grows in the prompt. But look at summary. It starts at 9 seconds and rockets to 50 seconds per turn by turn 20. Why? Because every single turn requires 2 LLM calls, one to respond and one to update the running summary. That doubles the latency and the summary itself keeps growing. On average, vector backends at 7 seconds, buffer at 10 seconds, summary at a whopping 32 seconds per turn, 5 times slower. The total wall clock time tells the same story. Qdrant and pgvector finished in 32 minutes each, buffer took almost 45 minutes, summary 3 hours. Here is where it gets really interesting. Let's extrapolate to 1,000 conversations. Buffer $4,303. It sends the entire conversation history every turn. By turn 50, you're sending 50 turns of history with every message. Summary $2,256. Better than buffer, but the extra summarization calls eat up the tokens. You're paying twice per turn. Qdrant $418, pgvector $416. That's a 90% cost reduction compared to buffer. Vector backends send only 4 relevant snippets per turn, keeping token usage flat regardless of conversation length. Put it another way, for every dollar you spend on vector memory, you would spend $10 on buffer memory for the same number of conversations. And the elephant in the room, does it matter which vector database you choose? At this scale, no. Qdrant, 7001 milliseconds latency. pgvector 7021 milliseconds, recall both 82%, cost 418 versus $416, tokens per run nearly identical. If you already run PostgreSQL, and most production systems do, just add the pgvector extension. Zero extra infrastructure, zero extra operational burden. If you are building a system that needs to scale to millions of vectors across many users, then Qdrant's purpose-built architecture may give you an edge. But for per session conversational memory, pgvector is a pragmatic choice. There is one finding I didn't expect. Every backend, including buffer, which has the data right there in the prompt, failed to recall the Wi-Fi password and bank pin at turn 50. This isn't a memory problem, it's a safety behavior. Claude recognizes sensitive data like passwords and pins and declines to repeat them even when they are explicitly provided in the conversation history. This matters for benchmark design. If you are evaluating memory backends and your test facts include sensitive data, you will get misleading recall scores. The failure isn't in the memory, it's how LLM's safety layer works. So, what should you actually use? For production chatbots where cost matters and almost always does, use pgvector or Qdrant. 82% recall at one-tenth the cost of buffer memory. For short conversations under 15 turns, buffer is fine. It's the simplest to implement, recall is perfect, and the cost hasn't had time to explode. If you already run PostgreSQL, pgvector, no contest. Add the extension, done. If you need to scale vector search to millions of vectors, Qdrant. It's purpose built for that. And summary memory, I'd skip that. It's the slowest and the most expensive after buffer, and it destroys the specific details your users shared. A 40% recall rate at turn 50 means it's forgotten more than it remembers. That's the agent memory showdown. 4 memory backends, 1,000 LLM calls, 5 hours of benchmarking on a DigitalOcean Droplet. If you're building AI agents and haven't benchmarked your memory backend, you're guessing. The difference between the best and worst choice here is 10 times the cost, 5 times the latency, and twice the recall accuracy. So do not guess, measure.